Hello and welcome back. The project today is a little bit different. Well, it's still a machining project, but it's a little bit different in the backstory. I was contacted by one of the local schools in my area, and they had a metalwork teacher that had left, so they wanted to ask a few questions about the machinery and stuff in their metalwork shop. So I offered to come down to the school and have a look at the machines and discuss the questions that they had. And in that visit, I found out that they had purchased this quick change tool post here, but it does not fit onto the lathe. So this block here that goes into the cross slide is a lot thicker than the existing one that is on the existing tool post. So it's quite thin here, and there's not a lot of room in the cross slide to hold this whole big piece here. So I said to the guy, look, I can make up another piece that will fit onto here. Incidentally, the thread here is too big, so you can't just screw this piece onto here and replace it. So yeah, I said to him, I can make another piece or machine up another piece so that it screws onto the bolt that comes through here and it sort of fits into the existing cross slide. So that is what this project today is about. Now, like there are many ways to skin a cat, there are many ways to do this project. So one option is to just make this part from scratch. This part is in total 10 millimeters thick there, and this piece here is about 5.5 millimeters thick. So I could use a bit of 10 millimeter plate, although that would be quite hard to hold in the lathe because I've only got 5.5 millimeters, or what's that, about 1/4 of an inch to hold that in the lathe, and I wouldn't want that to come flying out. I do have some 75 millimeter diameter round bar. However, that is the AISI 52100 steel, which is a bearing steel. Very, very hard, and I don't fancy turning that up at this point, so I think that one might be off the cards. Another option is to just use the existing block here. So I did notice that it's pretty much the same width as that. So what I could do is just mill down the sides to this width and then mill down some flats. So I actually have, instead of a round circle here, I just have a full flat in here. And I think that will be okay because this part does slide out of the thing. That recess is not going into something to register on anything. So I think it's just there to stop it moving sideways and to be able to slide in the groove of the cross slide there. So I think that option is probably the best one to start with. I can use the plate that's already here, and I just need to mill it down on the milling machine, and there is quite a bit to take off. So this is about 16 millimeters thick. So I've got to take off 6 millimeters to get to this height, and probably around about 10 millimeters to get down to this height here. So a little bit of work on the milling machine, but I think we'll be okay on that. The first thing I do is machine down the sides so I get it to the correct width. I start with one side and then I measure that up just to make sure I'm still on track. That looks good, so I continue on with the other side. So here I'm taking the arbor out of my mill and I'm putting in the face mill. Now I really like this face mill. It hogs off the material here. And the good thing here is that it's wider than the workpiece, so I can go through on just a couple of passes to get down to the right thickness. Okay, well I've got that part mostly done now. So that is the right width is our sample here, and also the thickness is bang on 10 millimeters, which is the total thickness there. So the remaining part to do here is then to just mill a bit of a slot on both sides there, about that wide, which is the centerpiece. Now the problem that I have is that I need to take off about 4.5 millimeters on these slots, and I've only got 10 millimeters to hang on to here, so it's going to need to be lifted up 5 millimeters out of the vise. And the problem I have is my parallels only lifted up to 4 millimeters out of the vise, so I don't think that's going to work too well. So what I was thinking of doing is, instead of putting it in the vise that way and having the milling cutter go along this way and risking cutting into my vise, I was going to put it in the vise that way. So the vise jaws will be here and here, and then I can use the y-axis to mill this way. So this little bit will be overhung off the edge of the vise, and of course I'll need to make a spacer that length to put on the other side of the vise to keep it all parallel. So I think that's going to be the approach to mill these slots. So you saw I was using this face mill or shell mill to do the surface here, and I bought this not too long ago, and I've used it a couple of times, and it is a very, very nice tool. Now I've always wanted a face mill for, you know, single pass milling of wider stock instead of backward and forth with a 16 or 20 mil end mill. So I did a bit of research, and there are hundreds of different types out there. So anyway, I just wanted to have a quick talk about why I chose this one here. Now this has 5 inserts on it. There was a smaller one and it only had 4 inserts. So I got the slightly bigger one. It comes with a MT3 taper. I think I had to buy that separate, but I bought it from the same people. So it fits straight into the mill, and the draw bolt holds it in nice and tight. So that's kind of what I wanted here for cutting, you know, bigger surfaces. I didn't really want to buy a face mill this big and then put it into a collet. So these inserts, as you can see, they're 5-sided inserts. So you get, you know, 5 edges here, so you can just loosen them off and rotate them around if you chip off the corner. And the good thing about this face mill here and these inserts are these negative rake inserts, so they're flat or straight sides. So I don't know if you can see it on the camera here, but the top where the insert is sort of angled like that, and it's angled a little bit like that as well, machined into this piece here. So what that means is the rake angle is built into the face mill, so you can have these negative rake inserts. And the benefit of that is that means that if I go round all 5 corners and they're all chipped off, I can actually get this insert and turn it around and then use the other 5 corners on the other side. So basically for each of these inserts I get 10 lives out of them. And I'm all for saving money and getting the most out of my tools and things like that. So 10 lives out of the inserts is, you know, really, really good. I kind of discussed this a bit on another video that I did recently, and that's on the CNMG inserts for lathe tools. I'll leave a link in the description for that video, but again here you can see that the lathe tool is, or the tool piece itself, is angled, sort of exaggerating, but down like that. So this is again a negative rake insert, so it's flat down the sides, or right angles across the top and down the side. And I get, for this particular tool, I get these 2 surfaces here, and then I can turn that tool upside down and get another 2 surfaces or edges to use. And I actually do have some other tools which have a different shape cut into them, so that I can use these other edges here. So out of this insert I can use all 8 of the corners there. Alright, so let's move on and get this milled out, and then this part will be finished. Now this is not the best setup, I don't think, and that is why I'm taking very, very light cuts here. I eventually get down to the size that I need, and this is what I was talking about. The cut is lower than the jaw of my vise, so I had to hold it in the vise this way. I turn the part around and proceed to cut down the other side to the same depth. And then I go ahead and just take off the sharp corners with the belt grinder there. And I also give those other corners a bit of a round off. I clean the parts up in acetone and I start to blue them with some cold blue. Now the threaded rod here, I didn't really take anything off it, I just cleaned up the end on the grinder so it had bare metal, so I had to blue that as well. Once the bluing was done, I neutralised the chemical reaction with water, and then I oiled the parts up to stop them from rusting. Lastly, I assembled the tool holder back together. A few days later, I went back to the school and fitted it back onto the lathe for them, and they were very happy with the result. That's my contribution to the school. It was a good little project and happy to get them up and running again. If you like this video, please click on the like button. And if you want to be notified when I release new videos, then click on that notification bell. I hope everyone has a great day, and once again, thanks for watching.